speaker for this session to the floor, M Monshizadeh. Here she comes. So please excuse if I misspelled your name.
Yeah, you can call me
Musha. Thanks a lot. So she will talk about security requirements for NFV in TAS, telecommunications networks as a service. Manish has over 16 years of experience in the telecommunication industry. The last 12 years of her career have been at Nokia. Since 2014, she has been working as a security specialist in the research department. She has experience with LTE and a PhD from the Electrical School of Aalto University. Musha, please provide us with your presentation.
If I can find it.
Switch. Did you spot it? Linda, Nicholas?
Not
here it is.
Okay.
Okay?
Yes, thank you. Okay. Hello everybody. Today's presentation is on NFV security for a platform called telecommunication as a service. Actually, our presentation is...
Can you move a little bit slower to the microphone?
Yes. Our presentation is based on a journal paper that I had recently with a colleague. And in that journal paper, we introduced a new telco cloud platform for mobile operators. Here we try to consider more NFV and SDN security and see how much it is mapped to OP-NFV group security activity. In this presentation, first we go through virtual operator, cloudification, their security aspects. Also, finally, we propose a security framework for these virtual operators. We consider a scenario that several virtual network operators share same network resources. And to orchestrate and manage these virtual operators, we use a platform called telecommunication as a service. In our study, NFV refers to any kind of software or function running on network elements over hypervisor. For TAAS security, we consider 5 main domains: data security, hypervisor, VM, SDN, and NFV security, and application security. Part of these domains are covered by OP-NFV security group, that later we go more detail in this part. First, we start with NFV threats and mitigation mechanisms. We consider 3 attacker profiles: intra-MVNO attacks, while one malicious employee tries to attack its own network resources; inter-MVNO attack, one MVNO tries to attack competitors or other MVNOs, or any kind of attack by mobile end users. The mitigation mechanisms that we considered for NFV are logical network validation, secure boot crash and crash protection, performance isolation, VM AAA, and software reliability. Logical network validation, we consider any kind of protection mechanism that supports control plane, user plane, management interfaces, routing, in case any malicious loop happens on VNF, or unavailability of our management interfaces that happens because of network failure. Secure boot is when one VM or non-authorized VM tries to have access to our hypervisor OS and change the BIOS setup. And crash protection, in case of the crash, some data still stays on the VM and later unauthorized access would be to that data. So we should make sure that data is removed. Performance isolation is in the case that one malicious virtual machine try to abuse hypervisor resources and cause quality of service degradation. VM AAA should be considered between VNFs or vertically between VNF and horizontally between VNF and vertically between VNF and management station or between VNF and application layer. For software reliability, we consider several scenarios where we have infected software that could affect all MVNOs that use the same software. We have test and monitoring interfaces that left open and could be targeted by backdoors. Any configuration change or software update on NFVs that cause system reboots and affect our MVNOs. And finally, if we have same private key and a stored password for VM images. We have a general picture for our mobile network. In infrastructure layer, we have all network elements, switches, and security appliances that are used for infrastructure layer. In control layer, we have SDN controller and SDN monitoring controller, our southbound and northbound interfaces, our virtual network, and finally the application layer orchestrator. Either it is network element application, like MME software or P-gateway software, or it is security application or monitoring application. As we see later in coming slides, most of the threats that we have in TAAS are common with traditional networks. Few of them for SDN and NFV are specific, and for application we could find one. The threats that can attack our controller and switches could be fake traffic flow or any attack on administration station. Mitigation mechanism are deep flow inspection. It is similar to DPI, but here we go through flow content. Here we have some of the SDN NFV common mitigation, like DPI for layer 4 above, shallow packet inspection for layer 3, virus scanner, IDS, security zone, PCRF, secure protocol, and monitoring protocols. So here, based on those three security or main security requirements, we categorize our domain attacks. We see some of the attacks are general for all three layers, and actually we should say very common with traditional network. They don't have anything new, so their mechanisms are also similar as traditional networks. Unauthorized access or any privileged access, like user to remove U2R, R2L, IP spoofing and phishing or probing. The similar mechanism that proposed in traditional network like AAA, firewall, PCRF, or secure protocol. Of course, we have encrypting and hardening the data, specifically only for data or data cleanup before switching the tenants. But we have some hypervisor, SDN, or NFV specific threats, like side channel attacks. While one VM tries to attack other VMs or tries to have access to other VMs. Stored password and private keys in VM images, or backdoors that target test and monitoring interface. So we have we focused on some kind of a specific mechanism like real-time hypervisor monitoring. It was in our previous picture where we discussed about SDN monitoring next to the SDN monitoring module, next to the SDN controller, VM isolation or traffic separation, unique private keys for each VM. Patching and closing test and monitoring interfaces. For application, of course, we have similar that we had in traditional network like spyware, cookies, poisoning, service injection attack, the similar mitigation method like encrypting cookie data, software update, and security patches. Regarding the availability, we have well-known denial of service attack when somebody or attacker tries to occupy network resources and cause network degradation, unexpected system failure, and data removal because of that system failure. It is the common for all of our 5 domains, or 3 domains here. The mitigation mechanism are redundancy, backup, IDS, and firewall. But of course, we have load balancing that consider in our platform for data and hypervisor. For hypervisor and SDN for availability, we have image loss, threat, configuration loss, misconfiguration, or unavailability of management stations. Configuration test or online configuration test, disabling not used test and debug interfaces, logical network validation for management station, as we discussed earlier in NFV, security mechanism are recommended. For application layer, here we have something specific, finally, not similar to the traditional network, and it is implementing of a system-related application in platform layer. Some application needed to be used by end users or by all virtual operators, so we consider them in application layer, but some of the application or softwares like network element softwares, MME software, P-gateway software, they are not needed to be used by or accessed by end users or even by either virtual operators that don't own the infrastructure. So we put them in the platform layer that uses hybrid cloud. For integrity, we have common threat, corruption, and tampering of data because of botnet, malware, or ransomware. Traditional mechanism like IDS, virus scanning, firewall encryption, or error checksum are the mitigation mechanism. For hypervisor, SDN, and NFV, specific threats could be software update and security patches, of course, or secure coding, but it is nothing different, again, with traditional network over there. Also, we have software and similar mechanism are used. We have VM isolation, security zone, and traffic separation, similar to VLAN tagging in our traditional network. Secure boot, that we use TPM solution, hashing and specific keys, and then secure crash. So in case that any kind of crash happens, we should make sure that data is removed. For application, secure browser, that is general. So finally, we have our cloud security framework for operators. Based on the layer that virtual operator are using or offering, they can use one or combination of the mechanism that we introduced. And it is in right side of the picture, it is visible. For infrastructure layer, we use all kind of hardware security that earlier we discussed. For hypervisor and controller layer, similar, all of them are explained. But something that here we consider is also cloud deployment. For infrastructure, we recommended private cloud because infrastructure or network elements are not needed to be used by all network operator or virtual operator, neither by any end user. So we consider it private cloud. For platform, we see hybrid cloud is here because maybe other virtual operators, they want to take advantages of this layer for implementing their features or testing their coding or software. And finally, we have public cloud for application layer because it should be accessible even by end users. And of course, as I said earlier, if we have a network-specific application, it's better to consider them in platform layer. Here we have OPNFV group security focus or activity. They concentrate on virtualization for hypervisor, network virtualization for data plane and vSwitches, SDN controller framework, OpenStack, and virtual storage. We had a discussion with them. They are partially covering data security, only for transport layer of data. For application security, they haven't done anything yet. for hypervisor and VM security, it's not fully covered. They just, in this stage, they are only concentrating on OpenStack, but they said it's ongoing work. Thank you. Any question?
Thanks a lot, Merners.
If there is a difficult question, I ask my colleague comes here.
So I have a question. Is OPNFV driving the analysis or also providing controls afterwards? So at the output, should there be some software controls which can be used in OpenStack? Or what is the objective?
Actually, they are not even in that level. What we discussed and what we got from them, they are just in the categorizing of the attack for OpenStack. And the common way that used also earlier for software security. So no software.
Okay, so it's in early phases of the analysis.
Yes.
Okay, so thanks a lot for this very comprehensive overview on where we need to look at in those networks. Thanks to the audience for staying that late. Very much appreciated by all the speakers to have you here with us. I wish you all a good trip home. See you next year again. And finally, also thanks to all the speakers here. Bye.